Hey students, let's talk about identifying quadratic functions from tables and points. How would you know if these set of points are quadratic? Well, first, if we look at the x values, I see that the x values are increasing at a constant rate. We know that these are going up by 1 every single time. So plus 1, plus 1, plus 1, plus 1. And then if I look at the change in y values, here's what I noticed. Plus 1, then it's plus 3, then we have plus 5, then plus 7. It's not going up at a constant rate, which makes sense because if all of these numbers were going up at a constant rate, we would have a linear relationship and not a quadratic one. But I do see that there is some kind of a pattern right there with our differences. Here's what I'm going to do. Let's look at the change in the differences. What do you notice? Do you see that the differences are going up at a constant rate? With these points, I see that our first differences are not constant, but our second differences are definitely constant. This is how we know that these set of points are quadratic. We need to always have constant second differences in our y values, and we need to have a constant rate of change in the x values as well. So again, these must be the same and these must be the same. So let's look at these three problems. Are these functions quadratic? Again, we start by looking at the change in our x values. I see in number 1 that our x values are going up at a constant rate. It is increasing by 1 every row. And if I look at the change in y values, at first it's going up by 7, then it goes up 1, then plus 1 again, and then plus another 7. But remember, we're not looking at these first differences with quadratics. We want to know if the second differences in the y values are constant. From 7 to 1, we take away 6. And then it's plus 0, there's no change. And then it's plus 6. Since the second differences are not constant, we know this is not a quadratic function for number 1. For number 2, first again, we look at the x values. Are they going up at a constant rate? Yes, they are. It is increasing by 2 each time. And then let's look at the first differences in our y values. I see from 8 to 2 is minus 6. Then we take away 2. Then it's plus 2 and plus 6. But remember, it's not the first differences. We got to look at the second differences to make sure it's quadratic. From negative 6 to negative 2 is plus 4. And then, hey, another plus 4 and another plus 4. We have constant second differences and constant rate of change in the x values. So yes, number 2 is quadratic. For number 3, all right, the x values are going up at a constant rate of 1 every time. And then for the y values, what do I see? 12 to 3 is minus 9. Then it's minus 3, then plus 3, then plus 9. And now for the second differences, we are going up 6 here. Then we go up another 6. And then we go up another 6. So this is quadratic.